construction projects tend to be now more and more technically complex, but especially contractually complex projects where our guys on site tend to spend way too long on meetings, on compliance, on procedures, and they have less time devoted to actually building, to actually thinking on how to build a project. So our goal is to basically to develop or to provide our team on site tools to help them build more efficiently, meaning improving the project controls on site. That means having real-time measurement of the project progress, real-time control of the resources being used, and so on. And to do so, what we need is basically data, as you said. So what we need to consider is that the project site, which is made actually of different work units, like you can have earthworks, you can have a TBM tunnel, you can have conventional tunnel, and so on, where you have lots and lots of equipment on use simultaneously and in different locations, which are all potential data feeders. Many of the modern construction equipment, they already have data capability. They have the capability to provide you with data that you need to collect. And that's the easy part, actually. What we tend to focus is in how to process that data to actually be able to feed to our project team with information that is useful. For example, type of KPIs, thinking on earthworks. Earthworks, what finally you got is a lot of dozers, dumpers, and so on, moving along kilometers of alignment. And what we provide them is automating the mass haul of the soils involved. KPIs related to the performance measurement, for example, of the each and of the equipments being involved for each of the dumpers, measuring the cycles from the time they are loading, waiting time, downtime, transport time, and then the time to get back. Why? Because they have a parameters. You have a project measurement or a project performance ratios that you have considered, and you need to be able to determine real time if you are complying with that, or the other way around, if you are overproducing, and that's great, or if you are doing less. And problem is that when you are so much involved in reporting and in filling out forms and all that, and you need to do that because it's contractually, you are losing time in not being able to measure that. So we just give them the tools to be able to measure that. And we are, for example, doing that in a project in New Zealand, in Puhoi project, where we have the alignment 20 kilometers, monitor all the fleet. It's not the fleet management, but it's the data provided by the fleet management that we can put in use. Other type of parameters that we are measuring, sustainability, performance, being able to measure the footprint of our projects. How finally we are measuring kilometers, we are measuring fuel consumption. So we are able to estimate actually the CO2 emissions that are being produced in our project. And that's actual measure. It's not a figure that we are inventing or estimating, but it's based on the data that we are controlling. Other examples, TBMs. We have different TBMs operating in the world. We had the TBMs in, well, not now because it's completed now in the Route 2020 in Dubai, but also in Quito. TBMs are basically moving underground factories, fully censored. So what we are doing is using all that sensors to provide to our teams developing the project the information that they need. Shift management, operations, maintenance, performance, and so on. That's what we are doing now. Future, well, use all that sensor to also help them predict what it will be happening, so we can optimize maintenance, so we can optimize the parameters based on the ground conditions or on the past performance. So we are now working on today, but we are also working in how they can do better in real time based on the data that they have used the day before.
Drones have been around for a while now. There's a couple of things I think that are coming together now. One is that their cost is coming down, so that they're much more accessible and commercially more viable to use. But also some of the accessories that can be attached to them are also coming down in price. Things like laser scanners and high fidelity cameras and 360 cameras. So And I don't think it's just contractors that are utilizing them. I think clients are seeing the value in them themselves and sometimes purchasing it themselves. Project management consultants such as us at JLL, we're finding great value in utilizing drones for things like progress monitoring, right? So flying drones means that we can get photographs more ubiquitously at greater frequency, whereas perhaps previously we might have only done this type of photogrammetry or photography on a monthly basis. We can now do it on a weekly or bi-weekly basis. Some of the sort of unexpected outcomes, I guess, are the fact that we can quickly create meshes of our sites and then use those and compare them against BIM models, and that helps us to sort of monitor progress. It helps us to do a number of things, identify safety risks, and things like that. I think the next evolution of this is combining this data with autonomous robots that roam around on the floor, right? So I think that we're going to start seeing things like the Boston Dynamics Spot, the dog, and other robots of that ilk, which will have all sorts of sensors on them, and they'll be constantly driving around site autonomously, taking measurements of progress, of quality, monitoring safety compliance, and things like that.
So basically, we have now in our projects BIM model, and a coordinated model that comes from the design phase all along the construction stage and is finally deployed to our client or to ourselves if we are later on operating the infrastructure. So fact is, we are collecting data from the project as it is going, and we have a BIM model of that project during the construction stage. So next step comes together is embed the data that we are collecting into the BIM model. So what we are basically doing is trying to automate certain synchronization of the BIM model using the real-time data that we are actually capturing and processing from the site. For example, working on the automation of the as designed or as built model, the update of the planning or the scheduling, using this automating progress for monitoring, for example, using image processing, or cameras using image processing for inspection of the constructed elements, for the early warning or possible failures like a crack or something happening to the structural element that you have just built. Of course, that would be included image processing for the quality and so on, automated planning, improve decision making in general is the obvious word that could be helped. So you don't have just the building that needs to be updated in the office, which is great, but what you are actually incorporating into that model is everything that is happening and that is being monitored. So you have all the mass hall updated, you have all the task on plan, you have all track changes inside the model, and that's being updated simultaneously and synchronized between the reality and the digital world.